And in day one of this class, I think I made a statement, probably akin to what's important in terms of a mathematical education. One of the most important things, I think, is the ability to recognize patterns. Trying to develop that ability in this class, and the only way to do that is to give you some things that you can compare and contrast, which is why I'm not the biggest fan of sequential instruction. So I've got 12 functions on the board. I didn't write y equals, but all of these are y equals statements. So I've done that now. And you pause the video and take a little piece of scrap paper or something and just jot down all the patterns you see. All right, so take 5 minutes. Look at the functions. Take as long as you want. And I'm just going to make some general comments, and I'm sure that there are more patterns here to talk about than we will in this video, because I'm going to try to keep it short and sweet. I'm assuming you've taken the 5 minutes now and you've looked at these, and I hope that you came to the conclusion that x equals 4 appears to be very important. 4 minus 4 to the 1, 0. 4 minus 4 squared, 0. I mean, that's where you'd start. Right? Please pardon my dear Aunt Sally says start with parentheses. She at least got that right. All right. And then we do the hardest operations first, which is squaring in this case, cubing in this case, so on and so forth. All right, so x equals 4 seems to be very important. Now, what happens when you plug x equals 4 in, especially over here on the left side? This side, it gets a little more complicated here and with the sinusoids, but nonetheless, 4 minus 4 to the first, second, third power, absolute value, square root. You get a 0. And what did we do day one? I asked the student, I called on somebody and I said, I want you to multiply 9.42 times 3.981. Come on, give me an answer. Poor lad couldn't do it. I said, immediate, come on. What's wrong with you? I don't know the answer either, but I do know 9.42 times 0. I don't need a calculator for that one. So working with 0 makes computation pretty easy. 7 plus 0. 7.93851 plus 0. Can I remember what I just said? No. All right, 7.93851. That's good for me to try to remember. So I'm losing my memory as we speak. All right, so from a computational standpoint, and what do we do in math? I think we measure things. Kind of like in a race, the 100-yard, well, I'm dating myself, the 100-meter dash. Yeah, we measure from something. We measure from 0. Yeah. I think it's easier to measure from 0 than it is other numbers. Yeah. How far is 7.32 from 0? How far is 7.32 from 2.911? Yeah, we do need an emergency number for that one. Yeah. So 0 is really easy to work with. It also has geometric significance. 0 area. I don't care what numbers you plug in, multiplying times each other. That's a minimum. And with a quadratic, we look at minimum y values. Yeah. And it seems like patterns emanate from those minimum y values here. Yeah, some symmetry. Yeah. And I think that's true of points of inflection. I think the graphing form for point of inflection, measured change comes from here. And that's highlighted in these cubics, although they're slightly different. All right. So there's geometric reasons. I mean, if there's 0 area, then the smallest square, I mean, that's got some language attached to it. That's a square root. And so a lot of mathematics seems to be born from these simple geometric shapes. In fact, I can make this a cube. And then that's a cube root. Very important to attach geometry to what we're doing as well. But when we create mathematics, marker, I get to decide what to write to make something true. Now I know 8 years ago we had this thing called facts. And now we have alternative facts. But in math, I don't think we have alternative facts. I think something is either true or false for us. I think 4 plus 7 is 11. 4 plus 8 is 11. I don't think so. You might have alternative facts somewhere else, but I think in math, something's either true or false. What else do these things have in common? Maybe I should write equals y for each one, equals y for each one. Because I think those are equations. So 4 plus 3 equals 7. I think that's true. But as soon as I change the 7 to, well, let's not change the 7, let's just put a variable here. I think there's a moment of truth there, but you have to go find it. But if I make it a two-variable equation, and what do we do with equations? We solve them. I think there's an infinite number of solutions to this equation. I think I can come up with an infinite number of x's and y's where I can say, well, that's true. I think I can pick an x value of 1 and say my y value is 5. And I think I can continue to do that. And we've been looking at patterns. A 2 gets a 6, a 3 gets a 7. I don't have to look here anymore. I can just keep creating that table because I see a pattern. And we've been looking for those patterns, hoping you're paying attention to those patterns, because each of these equations, if I attach y equals, have patterns associated with them. And those patterns allow us to do what? To study the Three Stooges. Woo! Well, that's a sinusoidal pattern. The pandemic was an exponential pattern where there were a certain number of people getting sick. And that's the number of people, the area under the curve. And this function was doubling every 3 days, the number of people getting sick. Well, it's not a scary thing when there's only one person in the world, and 3 days later there's 2, and 3 days later there's 4. But we know what happens with exponential functions. At some point, they start to go up quickly, right? Like the world's population doubles every 20 years. Not a problem when there's only 20 people on the planet. A couple of billion people on the planet. Doubling every 20 years, well, there's social issues to be discussed. And there's also things that slow down that growth, like pandemics, right? And we use math to study all these relationships. And each calculation, what studies straight line motion? Well, something just went up fast, slowed down, and came back down again. All right, so we're going to do some of that in the second half of the term here. I'm going to do an awful lot of so that we gain some facility to work with these patterns. Let's just look at the cubic one. When I drop in a 4. Let's look at this one. 4 minus 4, 0. 0 times anything. I get a y value of 7. But that function goes through 4, 7. And it looks something like this. That's what it's going to look like. And it's also going to go through another location. In fact, all of these functions go through another location. Can you spot that? If you haven't already, can you try to look for that now? What's another x value that's user-friendly? Well, I'll give you a little clue. What's the second easiest number to work with in math besides 0? Hope you say 1, because I think I also asked that young man to tell me what 9.475 is times 1. And I think he was able to answer it quickly. So what number can I put in here to create the number 1? Well, same number here to create the number 1. Same number here to create the number 1. I'm hoping that you can see that each of these functions, we've already highlighted that location. I'm hoping you're seeing that location. 9 minus 4 to the 1 is 5. 5 divided by 5 is 1. And I get 7 plus 8. 9 minus 4 squared. Well, that's 25. 25 divided by 25? Uno. 8 plus 7 again. 9 minus 4, 5 cubed, 125 divided by 125. Uno. I get 15 again. Gets a little more complicated with cubics. What happens when I put 9 in here? 9 minus 4 is 5 times 10. That's 50. Huh. Look what I wrote over here. Minus 50. Interesting. Because when I put 9 in here, the 125s cancel. I get minus 42. Over here, I get 50. Let's see now, did I do this right? Minus 42. Oh, yeah, 50. 50 minus 42 is 8. And 8 plus 7? 15. I get the marker. I can make it happen. If that's what I need, I write what I want. Yeah, I'm studying what I want. Okay, quiero. Yeah, that's my new attempt at cutting down on cognitive decline. Learn something new. Try to push the brain a little bit. So I'm trying to learn Spanish. And I'm using a method on the internet. Can you imagine that I'm looking at something that's very repetitive? Yeah, every morning. Yep, I get to say, quiero estudiar español. See where I am a year from now. Well, that's whole nother matter. All right, so what do I want you to learn from this video? You got the power of the marker. You get to write what's true. Now you get to say 4 plus 3 equals 7. And I hope you don't say 4 plus 4 equals 7. Right? So look for the geometric reasons for why we're doing what we're doing. Look at the numerical reasons why we're doing what we're doing, and look for patterns. And I'm sure there's more to be stated here. Now let's just play with these here very quickly, because these are the ones we've done that are a little more challenging to see. So 4 minus 4 is 0. Anything divided by into 0 is 0. Anything to the 0 is 1. I like that. 1 times 5 is 5, plus 2 is 7. A 4 gets us to 7. 9 minus 4 is 5 divided by 5 is 1. Anything to the 1 is itself. 5 divided by 5 is 1. And I get 2 plus 13, which is 15. I don't know if I switched up here. I've got 4 minus 4 is 0. Anything to the 0 is 1. I got 7. And then when I put 9 in, I get this to the 1. So the 7s cancel and I get 15. I can do this. I can do all of this with the marker because I also have an eraser if I make a mistake. And then I can use these calculations to quantify relationships that I see out in the real world. And we'll give you one chance right now to make a connection. The marker, I'll do it with the marker. It's 40 inches high. Boom. Just maxed out at 73. So 40 inches high. Let's say a 0 gets me 40 inches high. And boom, after I don't know how long did it take to go up that high, went up to 73 inches. And let's say it took 0.3 seconds. 0.3 seconds. Can you write an equation using zeros and ones to manipulate this so we know when it hits the ground? Let's see if we can do that quickly. Well, that's the important number. X minus 0.3. I got to square it. So therefore, I've got 0.3 squared canceled. When I put a 0 in, what's negative 0.3 when I drop in that number, right? And I'm getting rid of it. Negative 0.3 squared. I've created my zeros and ones. What's the height of 0.3? 73 inches. And how do I get from 73 to 40? I'm going down 33. Oh, I like that. No, down 30. Yeah, down 33. Yep. And how close is that to the actual gravity in the room? I don't know, but I'm manipulating it. And could we then figure out when it hits the ground? Yeah, all I needed was this and this to do it from previous lesson sets. We've learned how to do that, but subtract 73 multiply by this number squared on that side, divide it by that number, take the plus minus square root and add 0.3. I'm not gonna do that now, the board's too messy. Okay, but look for patterns and understand why we're doing what we're doing. And hopefully that might move the needle a little bit in your ability to think mathematically. I hope I said everything that's true. No alternative facts, because 8 years ago we came up with this new term in life called alternative facts. And all right, safe and warm.